Hello, everybody who joined us from at the call. Thanks for joining us. My name is Cesar Escalante, and we are here to our monthly meetup discussion on design technology. Today is October 21st. It's noon here at the Bay Area, and good afternoon or good morning, whatever part of the world you are. Um, Before I get started, let's just quickly check if you get my audio. If you can let me know on the chat panel or in the question and answer that you can hear me, that will be great. Excellent, thank you. All right, you might be surprised that we are not longer, or we are not officially the San Francisco Design this SFCDI, Computational Design Institute. As I announced in the last meeting, the SFCDI has now turned as part of the AIA San Francisco Design Technology Committee. And today, it marks the first time that we have this monthly meetup under the same umbrella. Nothing's going to change on our end as far as the quality of the presentations that we do every month. But a few things that have changed is that we have a new monthly meetup initiative committee that's led by Dave Alpert, who's going to work with the names you see on the screen as the monthly meetup group. Again, one of the intentions of doing this is so that we can obtain additional leads for presentation, discuss new topics, improve the quality of all deliverables, and we will continue providing you with quality speakers relevant to our industry. Stay tuned to our announcements in the website you see in the screen. Another quick announcement, Autodesk University 2020, it's a few weeks from now. It's scheduled to be on Tuesday, November 17th to Friday, November the 20th. It's the first time Autodesk universities offer virtual as a result of the pandemic. And the registration is free. Don't forget to sign up on the screen, on the link you see on the screen. And if you sign up, please join us at the Computational Design Meetup organized by Autodesk. It's going to take place on November 19 at 10 in the morning. And you're going to have all the Dynamo rock stars from Autodesk facilitating the meeting, and myself. Event is free. Pencil that in your schedule. All right, with that said, I have two fantastic speakers for the agenda today. Achinta Bayat from Stantec is here to discuss her workflows on stadium design using generative design. Cynthia is a computational designer for Stantec, and she has worked with the practice technology team for several years. And after her presentation, join me with Sig Rubel on the topic functional programming and the digital twin. Sig is the president of the A Design Plus Consulting, specialized in data-driven processes for the AEC industry. All right, with that said, feel free to ask your questions in the Q&A channel. Myself and Gabriel will be monitoring the panel and relay your questions to the attendees. So let's welcome Cynthia. There you go. Feel free to share your screen.
Okay, hello everyone. I hope everyone's staying safe. And with that, let's move into the stadium seating bowl optimization workflow that I developed. I'm Achintya Bhatt. I am a computational designer. As Cesar introduced me, I work with Stantec, based out of our Vancouver office. I'm part of our global innovation team, and I am part of the computational design and data analytics team within that. And my background is in civil engineering and project management. And with that, let's jump into the stadium anatomy. So at bare bone level, just the skeleton of the stadium, you have an event level, the lower bowl, a concourse or a walkway, and an upper bowl. And when we are designing a stadium, the most important thing is always the sight lines. So you need to make sure that irrespective of where our spectators are sitting, everyone has unobstructed view of the event level, because most of the time they're paid an exorbitant fee for the tickets. So, and in order to optimize that, the parameter which will help us is a C value, which is basically the gap between the sightline of the spectator with the spectator sitting in front of them. So that's perpendicular distance. And the formula that is used in order to calculate that C value, it's simple, basic math, trigonometry. And this is the formula here, and some of the parameters that are required are the seating, the row depths, and also the step heights here, which are called T and N, and also the vertical and horizontal distance from the focus point, which is at the event level, to the eye of the spectator in each row. So these are the parameters that are required in order to calculate the C value, which will let us know if the spectators have good sight lines. So with that brief intro, let's move into the Dynamo scripts, the spaghetti monster. And the way I will go through this is first, I'll dive into the Dynamo script. Then I will show you how I moved it to Refinery if you're using Revit 2020, or if you're in Revit 2021, the generative design add-in. And I'll also briefly show how you can export the seating plan to Power BI as an interactive map if you want to do like additional analysis, maybe like cost analysis or something like that. And then finally, how you can push it to Revit. Some of the parameters which I've assumed here to be as constants are my site size, the field size requirements, and also the number of levels I would have in the seating bowl, the walkway depth, the width, and also some of the exit requirements. So first things first is the number of rows you would have in the seating bowl. So for that, our site size is fixed, the radius or the dimension of the field is fixed, and the F is the focus, which is the distance from your event focus point. All of that are like parameters which are fixed. The variable here is the row depth, which we'll be using for optimization study. That's not fixed. And based on that, it will calculate the different number of rows that you can have in the stadium. And then once we have the row depth, we can offset each of these boundary curves and then get the row curve location in the horizontal, like a flat plane, XY plane. So, and it's the simple math. For the first row, it's just going to be row depth. Second row, it's going to be row depth into 2, and so on. So basic linear progression. So we would be thinking that should directly give us the horizontal distance, which is the D value for our formula here. But then that row offset is just giving us the edge, the back where the seat would be attached to. But then the eye of the spectator, there's going to be a gap. So which can be about 115 millimeter. Also, this entire demo here, which I'll dive into, is all in metric system. I'm based in Canada, so we use the metric system. So I don't know how that comes up in imperial. So you can change that input. And then once we have the row offsets, the other next parameter is finding out the step height. And again, the height or the riser height is a variable which you will be using for the study. And for my level 2, I've given an additional height because there's a walkway in the middle, people are walking. So just to make sure the sight line is not obstructed, an additional height there. And that's it. It's a variable, so we don't have to set anything. That will give us the riser height. And with that, we can calculate the R, which is the vertical distance from the focus point to the eye level of the spectator for each row. So this is the ground level. So for the first row, it will be just the step height. For second row, it's going to be step height of row 1 plus step height of row 2, and so on. Again, linear progression. But the one thing that we need to note here is this height, which we would add up, would just be the base of the rows. So we need to add an additional value here, because when a person is sitting, there's a height from like the foot to the eye level, so which is about 1.2 meters for an average human being. So that will add up and give us the R value, which is the vertical distance. So once we have these two, we now know where our row edges would sit in the seating bowl, and also where the eye of each spectator in each row would end up. So that gives, so we are just using these curves, which basically show where physically it would be. And then with all of, now that we have all of these parameters, we can calculate the C value. But I would like to mention again that the row depths and the riser heights, the N values, are variables. We haven't fixed it. So that is what we're trying to optimize here to make sure that we get the good C values. And I've broken down the C values into 5 ranges. Anything below 60 is not good at all. Above 150 is very good, but then you would not be fitting as many people as you can. So I think I was looking more for around 120, which is very good. People can still see if someone's standing. And also gave some color coding, just visually when I look at it. If something is red, I know it's below 60. So, but all of this just gives us just the row edge curves, right? But I don't have the actual geometry. So what I did is taking a point on each of these row curves and dropping them down by the riser heights, and then joining all of these points gave me the profile of the seating bowl. So now I have the boundary curve, and I also have the profile. And with that, I can generate the seating bowl geometry using the solid by sweep node. So I won't dig into this deeply. Feel free to reach out. It's basic, finding out points, geometry translation, and generating curves to get the profile curve. Once we have that, we can generate the seating bowl geometry. But then we also need to consider that there will be exits. So from each of these curves, we can get the length of the curve for each of the rows. And seat spacing is, again, a variable which we'll be using for the study. You can set a range for it. It's a pandemic. Now, if you want, you can set up even like 6 feet. And that will give us the total length divided by the spacing will basically give us the number of people you can sit in that row. But then depending on your regional requirements, you would need to provide a certain number of exits with a certain number of rows. So just doing simple divisions there to get the number of exits. One thing to note is that the further away you go, you would need more exits, whereas closer to the event center, you would need less because the perimeter is smaller. So I just chose to pick the maximum, the last one here, and then that way you're actually seating less people you can than here closer to the event boundary, but you can make some changes, add maybe like as you go away from the center, you can add like convert this and make like 2 or 3 exits here, so on. But for the simplicity's sake for this demo, I've kept it like this. And then once I got the number of exits that I need, I basically, again, used the profile curve, selected certain points, and generated exit solid geometries, and then used the geometry split to create those openings in the seating bowl. You can also, if you already have a mass in your Revit model, you can use that, array it as many times as you need, and then use that to create your openings in the seating bowl. There's no right or wrong way for it. Once I have the seating bowl here, what I did was you can export it to Revit using the direct shape by geometry node in Dynamo. I actually like the springs node one because, as you can see in the previous one, when you use the out-of-the-box Revit one, it creates these triangulation, which I'm not a great fan of. So the springs node gives a more clear geometry in Revit. Or you can also break it down. What I did here is exported the seating bowl, took all the top vertical and horizontal faces, and exported it to get the perimeter curves, and used the floor by outline type and level node in Dynamo to get it as a floor component into Revit. So there are multiple ways you can bring it. And so this is an overall picture of how the Dynamo script looks. What I would like to bring attention to is what I used with Revit 2021 is the data gate node, which I really like. What it helps is if you set it to close here, it knows all the rest of the script, which is after this data gate node. It won't run it. Like when Refinery is running, it won't run that part of the script. It will just generate the rest of the script here, which is all I need in order to do my optimization study. I don't have to actually generate my seating bowl geometry and create exit openings and so on. All I need is those seating row curves, which will give me all the values I need to generate my C values. So that, I think, is a very good functionality. And yeah, and then once you have the script, if you're in Revit 2020, what I did here, you can click on the Refinery option on the top. And right now in this demo, I'm running like just a cross product. So it's just a brute force algorithm generating for all options possible based on the variables I've set. It's not trying to optimize anything. There's no fitness condition given. And it's generating all the possible options. And then after that, it will look something like this. And then it's up to me as a designer or an architect. You guys can like select what are your best options. For example, I'm trying to make sure I don't want any seats which have a C value of less than 60, because that's just poor sites for the spectator sitting there. And then you can select the best option and click on it, and then use that as your input for your Dynamo script and push it to Revit. With Revit 2021, you can use the export for generative design button on the generative design tab here. And what that will do is it will save a version of the script in your C drive. And when you go into Revit, you can go to the Create Study tab, select on this particular script you want to run, choose what are your variables, set your goals. Here, I'm trying to minimize the seats which have the C values less than 60, maximize the ones which have more than 120. Just for this demo, I'm just using a very small population size there. And takes its time, it will start running. I'm going to forward it a little here. And as you can see here, that as with every generation that it runs, it's trying to optimize it, choose different parameters. Like for example, right now, the third generation, it's actually has lesser, it's not that optimized because it had some which had a site value in the range of 90 to 120, whereas previously it was giving most of them like in the range of 120 to 150. And it will run all of these options for me. And I'm just gonna forward it. So once it's done, so this is it, the option is giving me all of my seats are in like about 120 or 150 range, which is very good. Then you can click on the Create Revit Elements button there, and it's gonna run the part of the script, which I had closed using the data gate node. And it takes some time to do it, to create all of the geometry and then push it to Revit. So that's how it looks. And you can, if you're not happy, you can create, run your optimization, script again, given more number of generations and increase the population size or change your parameters. And also another thing, if you want to do more analysis, if you want to put some costings, do a reporting or something, you can push the seed plan as an SVG file using the SVG export node. So just explode your geometry, take the top surfaces, get the corner points and export, just export it to this node. And what it will generate is actually a vector file. But when you open up, this is how it looks. It's a text file. And within Power BI, which is the BI tool from Microsoft, which is free, there is a custom visualization called Synoptic Panel. And you can use that to generate your own custom maps. And what you can see here, in addition to the points, the vertices, it also has an ID, which is not created by the SVG export node. So you can do that by yourself, like import the SVG file created. You just need to add the IDs for each of these polygons and then export it again. And that way it's going to look like this, how the Synoptic Panel visual and Power BI requires it to be. And then you can bring it into Power BI as a flow plan or a heat map, and you can add as much data as you want if you want to like show it with your clients, add some costings or so on. So yeah, so just summarizing, we generate a Dynamo script, use Refinery to optimize it, and then push it to Revit. And if you want, you can also export it as a map for Power BI for additional analytics. So I think that's about it from my end. Feel free to ask questions at the end of it, because now Zig will show some of his amazing work.
You must be thinking of a different Zig, but thank you. That was really fascinating. Let me just share my screen. Okay, and okay, go into presentation mode. So I wanted to start talking about the concept of a digital twin. And, this image is from the Digital Twin Consortium, which is a industry group that really talks about digital twins across all different kinds of industries. So they have a digital twin group that talks about aerospace. They have one for medical devices. They have one for oil and gas. This is the infrastructure working group, which I am a part of. And I wanted to try and define what a digital twin was. And what I realized that the digital twin consortium themselves don't have a singular definition of what a digital twin is, because the value of the digital twin changes over the life of the object. So what I'm going to be focusing on in terms of what the digital twin may or may not be is around the very beginning of the project, in the requirements and opportunity part of the project, and the operations. And I know a lot of probably the discussion that has been had is around design, construction, and commissioning. I'm purposely going to avoid that, not because it's not important, it's very important, but that's not what our tool does. So when you look at the different forces in healthcare, there's the technology side, in terms of how technology in terms of what treats healthcare is changing. And those of you who might have an Apple Watch or a Fitbit or whatever knows that you're a walking electronic health record. Uh, that, on top of what we know about diseases, is changing. A year ago today, I don't think anyone on the call knew what coronavirus was. And this whole nature of medicine is really turning things on its head. Unfortunately, as architects and designers, we create a design for a building for one use, but it really needs to adapt because the diseases and technology need to adapt. And we don't really have a single platform to allow that to happen. So when we look at how do we model the operations of a hospital, you could either forecast it, which is what a lot of people do, or you could provide a prediction. And I apologize for the mind spinning of the model, but I thought it was very indicative that even the weather, quote unquote, forecasters or predictors know that there isn't a single scenario that really represents reality. So the image on the left is what most of us see when we're watching the evening news, and the image on the right is reality. And one thing that I've learned by learning about statistics is that the weather forecasters always predict that there's a 5% chance of rain, even though the skies are blue and you don't see a cloud anywhere. So it's just one of those interesting facts. So in terms of what I want to talk about is what I'm going to be calling the zero data. So when you all know the level of development, there's 100, 200, 300, 400, and even 500. The requirements information is what I'm calling zero level information. So this is a diagram that I had prepared for the BIM handbook that's included, showing how the data could provide value. So this, of course, is the objects and the design of a particular project that we worked on. But the level zero data is all of this. It's the room data sheet, it's how the rooms interact, and it's all the utilization of the rooms. And especially in healthcare, maybe not in all buildings, you could come up with a abstracted solution for your design before you actually start the design. And what we mean by that, this is just a sample of an exam room. So you have the room data sheet and all of the attributes, and those attributes are then linked to the Revit file. And then we were able to have a bilateral link within Revit and Dynamo to the Excel room data sheet. And then more importantly, how the rooms kind of combine and create a hospital experience can be tracked, and then you're looking at all of the room utilization. So one of the important concepts in this approach is that rooms are the atomic element of a building. maybe not all buildings because the stadium doesn't have that many rooms, but certainly for a hospital or even an office building, rooms combine to create floor levels, and then floor levels combine to create buildings. So just like elements combine to create molecules and molecules compounds, if you treat the room as the fundamental object, I think the concept is scalable. So the way FastPlan works, and we're going to go into the details, is that we tie a clinical diagnosis, like my child has a cold, and that then is tied to a physical space in the building. And then we're able to determine, based on the different types of patients that come to the building, what kind of spaces are needed. And it's a bit of an iterative loop because you're never going to have one type of patient that comes to a healthcare facility. So I'm going to show a couple of case examples, and then I'm going to show you the actual tool. So this is an example for a new health system in Saudi Arabia where they had no data. It was a brand new city called the King Abdullah Financial District. And the client initially thought of it as a more traditional medical solution, which is, not to get into too many details, but it's 3 beds per 1,000, meaning for every 1,000 population, you require 3 hospital beds. What we were able to show with a more outpatient-based approach, you only needed 1.2 beds per 1,000, and the overall cost for the health system was less than half. So the benefit of modeling these requirements is really powerful, because then you're really looking at what we say, designing the right building. Another project that we did that's under construction is for a cancer hospital in Shantou, China, which is about an hour and a half north of Hong Kong. And this is where the client intuitively felt that the doctors were asking for too big of a hospital. And this is where we were able to meet with the doctor, model their hospital, and convince them that some of the information, some of the spaces that they were asking for, they really didn't need. So because of that, we were able to reduce the size of the hospital by 38%, along with leaving plenty of space for a future hospital to be added, and increase the research building by 42%, which is what the client really wanted to do. They wanted to invest in research. So it's not always about reducing money, it's really about enabling the client and what they want. Another project that also is under construction, this is where the client had to make the difficult decision of closing a hospital. And they thought that they would need to double the emergency room size in the hospital that was staying open. And unfortunately, they didn't have enough space in the existing hospital to double the ER size. So in this case, instead of just using publicly available data, they their declaration and show, instead of needing an additional 30,000 square feet, they could get away with just adding 5,000 square feet. So we weren't able to eliminate everything, but we were able to have the project go forward and provide the services that they needed. And then the last image that I wanted to show you is that it isn't always about saving space or minimizing space. This is a project, again, in China, where the client gave us a space program for an existing hotel that they were converting into a facility for new moms to stay there for a month. For those of you on the call who are a mom in China, it's somewhat common for a new mom to be taken care of for a month after she gives birth. And this is one of those facilities. And we were able to run a few dozen optimization schemes to show that by changing the room mix, you could actually increase your profitability by 45%. So this is the scheme that is going to be getting built. And again, there was no change in the overall design. So I am going to try and switch to the tool. Okay, just give me a second. All right. Do you see the screen? Yeah, okay, great. So this is our web app. It's a working prototype, so it's not ready for anyone to swipe a credit card and access. But basically, there's two different grouping of tools. One is the tools itself that I'll go through, and one is the actual scenario. So I will create a scenario. We'll call it Cesar's sandbox. Click on OK, and you should see Cesar's name showing up here. And the world's population data. I always like to try and pick a different country than the US because we all know what we have here. So since Achintia is from Canada, we'll pick Canada. So we'll just scroll up here, find Canada. And what that's going to show is a population pyramid of Canada. And you'll see there's a slight difference in that there are less younger people than there are older people compared to the US. And we're able to look 40 years in the future to see how the population is going to age over time. And that is relevant in healthcare because these are the patients that are going to need the healthcare facility more so than the younger, quote unquote, healthier patients. So I'm going to suggest that Cesar's healthcare facility is going to open up in 2025. We're going to make it a full-blown hospital. And Cesar doesn't know how many beds or doctor's offices that he wants, but he knows that the city that he's going in has 1 million people, and he's going to target 25% of the population, which is 250,000 people. So the other thing that Cesar needs to know is, well, what kind of services are going to be in this facility? So just for the sake of simplicity, we'll select all. I thought I select all. And maybe, okay, here we go. And maybe we're not going to have psychiatry because they already have a facility there. And the last thing that we can do is we could add existing key drivers or existing spaces because a lot of healthcare facilities are existing. So let me just scroll down to the next thing. So with all this data, now we're able to look at what is going to be in this hospital. So it's saying that we need 247 doctor's offices, 23 outpatient procedure rooms, 3 computer tomography machines, so forth and so on, 565 beds, and 162 ICU beds. And you may say, well, how did you really come up with that? So not that we're going to do it for all of these, but all of these key drivers can be quote unquote customized. So I'm just going to pick the MRI, and you can indicate how long an average procedure takes, how many hours the MRI is operational, and how much revenue each MRI procedure brings in. And that's going to tie to the financial modeling that I'll show you in a little bit. So let's say, so before I do anything, there are 3 MRIs right now. So I'm going to say apply the customized parameters, and I'm going to change it to 9 hours. So I want to see how many more or less MRIs are needed based on the shorter operating time. And I'm going to click on calculate and it'll do the math. Unfortunately, it does the math on everything, so it takes a few seconds, but it should be coming up. And now it has 6 MRIs. So again, not saying that this is the right answer, but it allows you to play with the different variables as far as what might be required. We also do a similar thing with staffing. So it's telling me that we need between 1,840 to 3,000 staff of doctors, nurses, and other healthcare providers. And what might be most valuable for your client is that we're able to indicate a financial model. So what the grossing factor is. So the default is 25%. Maybe it's 32%, meaning from departmental gross to building gross. What the cost per square foot is. I have no idea what the cost in Canada is, but let's say it's $800 a square foot. What your equipment cost is, what your staffing cost is, and how many patients are going to show up year one will make that 80%. And what this is telling me is that the investment for the hospital will break even in 2028. So again, we're not saying that this is the right number, but it allows the owner to say, well, that's quicker than I thought it would be. That's 13 years after it opens. Maybe I could spend a little bit more money on the project. So what if the construction cost is $900 a square foot? So I just changed that. I think I need to hit calculate. And the 2028 is now 2028. So there was no change. So it reinforces that the operational costs are the key drivers for that. Now, in terms of a generative design perspective, what we're able to do is download some of the key data that is created from the program. So we're able to download all of the space program attributes from that. So I'm just making my screen a little bit larger. So here's Cesar Sandbox, and then you start seeing the different population variables, your capital costs, operating costs, building costs. So you're able to take that out of our tool and put it in PowerPoint or Excel or whatever file that you're going to be showing your client. And the other thing that we have is we do have many of the rooms done in Revit. And I don't have Revit on this machine, but all of the rooms you can open up in Revit, but this is a PDF of the room. So we have a low fidelity and a high fidelity object for the room that is auto-generated. And it allows the designer to just have a starting point of where to begin with their design so that they can start creating the design instead of doing everything from scratch. And I guess the last thing that I will show in the interest of time is we have a COVID-19 or what we call a surge analysis tool. So you're able to create a model looking into the future and indicating what the transmission rate is, the number of days of recovery, and the probability of severe infection. And what this does is this tells you for your ICU beds, how many patients you could handle without decanting or kicking out your patients, and how many patients you could handle if you are able to decant. So you'll see that in most cases, you don't have enough beds. So again, you can say, well, maybe you don't need 14 days to recover. Maybe you only need 7 days. So that will change the curve but it doesn't change the number of beds that are needed significantly. So maybe your infectious transmission rate is not as high as you initially had. And again, you can see what that does. And again, there's not a significant impact. So again, we're not saying that this is reality, but it allows the client to see how their facility might be used in a quick way, as opposed to the traditional way of kind of getting the client's requirements and getting feedback from them after you go back to your office. So that is all that I have. And I'd love to open it up to questions and hopefully also some answers.
Right, if anyone has a question, feel free to type it on the chat panel or the Q&A session, or raise your hand. I can unmute you as well.
I would have a question for Zig.
Okay.
The tool you presented is really interesting, as it enables to access and elaborate data. So for example, you examined the example of Canada.
Yes.
But there are a lot of, I'm from Italy, there are a lot of concern in Italy related to the growth of population, which is actually decreasing. And this has a lot to do with governative strategy around immigration. So some people believes that immigration will be the solution for the depopulation in Italy. Could your tool say something about what is forecasted for Italy in the next 10, 20 years in terms of population and also average age?
Yeah. So there, yes, I'm happy to do that. There's an awesome website that you should check out. I think it's called populationpyramid.net, which can graphically show you the information. So the data that we get, and it's the same data that the populationpyramid.net uses, comes from the UN. It's the World Population Prospects 2019 data. And I will change it to Italy. Where is it? Right here. So this is what the population is projected to be in 2025. And again, it looks like you have a lot of baby boomers that are getting older here. And then what it's projected to go to in 2060, and we only have data up until 2060,
Wow.
that you're just going to have a lot more older people.
Oh my gosh, it's gonna collapse.
Well, yeah. So what's interesting, as different as this this population pyramid looks like, I think Japan has one of the more challenging ones, because they already have a much older population. And another country, again, and I'm not at all trying to be critical, is Singapore. Where did here it is. And so right now, Singapore has a very kind of jagged population pyramid, but it doesn't really kind of smooth out. It stays the way that. So this really informs how our buildings are going to be used and what should really be designed. But yeah, I don't know if I answered your question or not.
No, thank you. And it's amazing how easy is it to get access to all this data.
Yeah, it's all free. I mean, we just we just happen to be using it. The data that we use that isn't free is the health incidence data, because researchers have to come up with those numbers and that information has to be, paid for. So.
I think there's a question from the audience. Jacob is asking, overall, how quickly can you design a hospital using your tool?
So great question. So this tool doesn't necessarily design the hospital. This just tells you what should be in the hospital. As a healthcare architect, I've always said that it takes as long to figure out what goes in the hospital than it takes to design and build it. So this will certainly shorten the amount of time because hopefully it'll bring certainty. But if you can imagine a large hospital project that may have several hundred beds, that takes a decade to figure out what's going to go in it. And then it's like, hurry up, let's get it done. So I'm trying to create a tool that will help the client figure out what goes in it so that they don't spend 10 years to do it. Now, granted, I made it look simple, that it only takes like a lunch break to figure out what's in a hospital. But the real challenge with any tool like this is getting the consensus of all the doctors and nurses and stakeholders that will take the time, which I don't think our tool is going to change. But instead of taking a decade, I hope that it would take a month or two. And then, of course, the idea would be that the design would be a lot quicker.
I think I do have a question. So you targeting owners primarily for this type of analysis or anyone?
Yeah, great question. So we are currently beta testing it with, as you suggested, owners, but I would say the largest portion of our beta testers are architects. We do have some builders involved in the beta testing because a lot of builders want to be moving upstream and offering higher value consulting. And we're also talking with a real estate broker who leases healthcare space so that they may have a leasable space that's available, but they won't know what could go in it. So this could help them figure that out for the owner.
And then to what extent do you think that there's value like connecting the outputs of your tool via some kind of bridge with different design tools? Is that something you're contemplating? Do you think there's any worth?
So yeah, so the hope for the value for us is that the Revit files that we create will all be consumed by Revit, and the user will be able to suck in the RFA files that we give them to quickly start the design and all of the different room types that will be in there. So the significant savings is that the project team that's working on it wouldn't have to spend the weeks or month generating all of those rooms because they come as a kit of parts. And some of the larger firms may have projects that they have done like that, but you're still going to spend time cannibalizing a project and not having clean rooms the way we have it set up. So that's the value that we're trying to create.
Thanks. I think we have time maybe for a couple more questions. Sean is asking for a Chinta. Have you successfully used your approach to non-circular or elliptical shapes?
No, I've used it on like circular or elliptical, but still symmetric. I haven't tried it on non-symmetric. bold design, but yeah, I think it will break the script because this one is currently considering everything is symmetric. So, but I definitely think it can be, yeah, very, like, I can change the script for it, but yeah, haven't tried it.
And has this workflow been used successfully in real projects?
Not on our, because Stantec hasn't had any like stadium design come up. We haven't got a stadium project in Canada, so haven't been used successfully. So yeah, but I'm sharing it. So if anyone is using it, let me know if it's successful.
All right. Well, I don't see more questions on the QA panel. There's nothing in the chat panel. If no one has an additional comment, I guess we will break it out here. Just as a reminder, this session it's recorded. I'm going to download it and post it in a YouTube channel by tomorrow or this week. And stay tuned for the next set of presentations under the Design Technology Committee in San Francisco. With that said, please let's thank you, Sig and Achintia, for sharing some of your work. As always, you will always be invited to come back at a future date and show more about the innovation you guys are driving within your organizations. All right, so on behalf of our group, thanks for attending and see you in a month. Have a good one.
Okay, thank you so much.
Thank you.
Thanks, everyone.